In this video, I'm going to take a look at a second very well-known trigonometric identity. And this matches up. I'll probably put a PowerPoint out here that kind of guides you through this. I like the idea of people really trying to investigate and find these things, because if you understand where it comes from, it's much better than me showing you where I understood where it came from. But anyway, what I'm going to do is I'm going to ask you to evaluate some statements and see if you see any kinds of trends, okay? One of the problems with the PowerPoint is I don't explain what it means to have like the sine squared of an angle or that kind of thing. So let me look at that real briefly. If I want to take the sine of 20 and square it, okay, if I wrote sine of 20 and then I put a squared symbol after that, it would be a little bit unclear. Am I supposed to square 20 and then I'm finding the sine of 400? Or am I supposed to take the sine of 20 and then square that? Okay, because that's a little bit confusing, and yes, you could do parentheses. You could, do this, or you could put parentheses around this, and you could get different outcomes. But anyway, it turns out that if I want to square the sine of 20, in other words, I want to take the sine of 20 and I want to multiply it by the sine of 20. Instead of writing the sine of 20 squared, okay, it's the sine function that's being squared, not the 20, okay? And so another equivalent way of writing this is sine squared of 20. In other words, I am taking the sine of 20 and I'm multiplying by the sine of 20, okay? The sine function statement itself is being squared, okay? So if you see this, this is what you're going to have to put in your calculator. Okay, take the sine of 20 and then square the answer that you get from that, or put big parentheses around the whole thing. And we're going to use this setup again and again and again. So it's really, really, really important that you know that those are the same thing. Okay, so if you put the sine of 20 into your calculator and you square it, and if you put the cosine of 20 into your calculator and you square that, and again, maybe you want to change the setup to look like this. Put that in your calculator right now, and assume we're working in degree mode here if you're in radian mode. And you should be able to work that out. And anyway, when you run the numbers on that, you're going to get, expecting a crazy decimal answer, that sort of thing. But it turns out you're actually going to get 1, okay? No pattern there, just got an answer. Let's see what happens if I make it a 50 instead. So I'm going to take the sine of 50, I'm going to square that. I'm going to take the cosine of 50, I'm going to square that, add those two things together, okay? And so you're running those numbers, you're taking a look at that, you're putting that in your calculator, you hit enter, and your final answer should be 1, okay? Now, I can give you values you know. For example, we know the sine of 60 is radical 3 over 2, and we want to square that. We know the cosine of 60 is 1/2. We want to square that, and we want to add them together. Well, what does that give me? That's 3 over 4, right? And that's 1 over 4. And that'll be 4 over 4, which is equal to 1. Okay? Did I prove anything there? No. Does it seem like we got some kind of a pattern here? Yes. Okay? It seems like if you take the sine of an angle and you square it, and you take the cosine of an angle and you square it, you add those two things together, it's starting to look a lot like we always are going to get 1. Okay? And my question is that always true, or was I just being kind of sneaky and I just picked a couple of examples that work and nothing else does? Okay? So let's try to do this algebraically. Okay? So what we're going to try to prove here is we're going to try to prove that the sine of an angle squared plus the cosine of that same angle squared is equal to 1, okay? And here's how I'm going to do this. I'm going to do this very similarly to the proof that I did before. I'm going to draw a right triangle, okay? We'll make this angle x, or maybe you could use a theta, doesn't matter. And all right, I'm going to do a little bit of labeling here again. I'm going to call this side A, I'm going to call this side B. Just like before, this side plus this side, if you take the square root of that, it'll give you the hypotenuse. So that's the square root of A squared plus b squared, all right? Okay, so I'm going to just do this statement. I'm going to see what happens, okay? So the sine of my angle is going to be the opposite side over the hypotenuse. So the sine of angle x is going to be a over radical a squared plus b squared, okay? We are squaring that. So this is the sine value, we're squaring it, okay? The cosine value is the adjacent side over the hypotenuse. So that's going to be b over a squared plus b squared, okay? We're squaring that entire cosine value as well, okay? Now, if you think back to Algebra 1, your exponent rules, if you've got a fraction, that exponent will apply to both the numerator and denominator, okay? Or you could write this multiplied by itself, and you could actually work it out. A squared, of course, is just going to be a squared. A radical squared, just going to give me a squared plus b squared. Okay, over here, b is being squared. The radical is being squared. Okay, we've got two fractions with a common denominator. Think about when I add 1/5 and 3/5. You add the numerators, denominators stay the same. So in the numerator, we're going to get a squared plus b squared. The denominator, we're going to get a squared plus b squared. And if you notice, anything divided by itself is going to be equal to 1, okay? So what I have shown here, if I take the sine of any angle and I square it, and the cosine of that same angle and square it, I'm always going to get 1, okay? So sine of 2 degrees squared plus the cosine of 2 degrees squared is going to be 1. Sine of 314 degrees, square that, plus the cosine of 314 degrees, square that, you're going to get 1, okay? Really, really, really powerful trig identity. Again, what are we going to do with it? That remains open to question. Again, most of the time, I'm going to write this as sine squared of x plus the cosine squared of x is equal to 1, okay? So get used to that notation. It means the sine function itself is being squared, not the x. It means the cosine function itself is being squared, not the x. But that's what's going on. We will do more in future videos.